Hi everyone, in today's session we are going to discuss about machine learning and its applications. I am NS Kavita, Associate Professor of Department of Information Technology, Erode Engineering College. So today we are going to discuss about the introduction to machine learning, its definitions and theory, and why it is important, and how ML is used, and what is meant by learning. And then we are going to say about the relation to animal and human learning and its impact on information science. And then this machine learning tutorial gives you an introduction to machine learning along with the wide range of machine learning techniques such as supervised, unsupervised, and reinforcement learning. And then you will also learn about regression and classification models, clustering methods, and various sequential models. And then this tutorial also provides basic and advanced concept of machine learning. This tutorial is mainly designed for students and working professionals. So now let us see about the basic information of machine learning. Usually machine learning is a growing technology which enables computers to learn automatically from past data. It uses various algorithms for building mathematical models and making predictions using historical data or information. And then currently it is being used for various tasks such as image recognition, speech recognition, image filtering, recommender system, and so on. Basically, machine learning helps a machine to learn from the past data and build a statistical model based on their learning. So now let us see the detailed explanation of what is meant by machine learning and its definitions. Usually in real world we are surrounded by humans who can learn everything from their experiences with their learning capability, and we have computers or machines which work on our own instructions. But can a machine also learn from experience or past data like a human does? So we use the role of machine learning. In artificial intelligence, there is a subset which is called as machine learning, and machine learning has a subset which is called as deep learning. So machine learning is mainly concerned with the development of algorithms which allow a computer to learn from the data and past experiences on their own. The term machine learning was first introduced by Arthur Samuel in 1959, who creates a machine to learn automatically from the past data and on its own. So let us see the detailed definition of machine learning. Machine learning enables a machine to automatically learn from data, improve performance from experience, and predict things without being explicitly programmed. And then there are two ways that a system can improve. They are by acquiring new knowledge and then by acquiring its behavior. In acquiring new knowledge, there are two skills and fact. And then by acquiring behavior, the problem should be solved more accurately and more efficiently. So these are the ways the system can be improved. Now let us see the internal processing of historical machine learning. Machine learning uses training data and build a mathematical model that helps in making predictions or decisions without being explicitly programmed. Usually, machine learning brings computer science and statistics together for creating predictive models. Machine learning constructs or uses the algorithm that learn from the historical data. And then a machine has the ability to learn if it can improve its performance by gaining more data. And then machine learning has various features such as it uses data to detect various patterns in a given data set, and then it can learn from past data and improve automatically. It is a data driven technology, and machine learning is much similar to data mining as it also deals with the huge amount of data. Now let's move on to next slide, which is learning. Now let's see about learning. Herbert Simon said that learning is any process by a system improves performance from experiences. Usually learning means gaining new experience. Learning is a process where we can gain more experience. For example, if a child learns to draw, write, read, eat, etc., he learns a new thing from their past experiences. And then we can see about task. Usually, task is defined as a work. There are various classification in a task such as categorization, clustering, problem solving, prediction, and other types in it. So in the next slide, we are going to see about why do we study machine learning comparing to developing better computing systems. Usually, we develop systems that are too difficult or expensive to construct manually because they require specific detail, skills, or knowledge tuned to a specific task. And then we develop systems that can automatically adapt and customize themselves to individual users. There are two types such as personalized news or mail filter or personalized tutoring. And then we discover new knowledge from large databases. For example, we can take market basket analysis and then we can take medical text mining. There are various needs why we want to study machine learning. Let us see one by them. Firstly, the need for using machine learning is increasing day by day. The reason behind the need for machine learning is that it is capable of doing tasks that are too complex for a person to implement directly. As a human, we have some limitations as we cannot access the huge amount of data manually. So, for this, we need some computer system, and here comes the machine learning to make things easy for us. And then we can train machine learning algorithms by providing them the huge amount of data and let them explore the data, construct the models, and predict the required output automatically. And then the performance of the machine learning algorithm depends on the amount of data and it can be determined by the cost function. With the help of machine learning, we can save both time and money. So these are the main reasons for the need of machine learning in today's life. And then there are so many importances of machine learning which can be easily understood by us. Currently, machine learning is used in self-driving cars, cyber fraud detection, face recognition, and friend suggestion by Facebook, etc. And in various top companies such as Netflix and Amazon have built machine learning models that are using a vast amount of data to analyze the user interest and recommend product accordingly. Now let us see the growth of machine learning in various fields. They are rapid increment in the production of data, solving complex problems which are difficult for a human, and then making decision in various sectors such as finance, and then finding hidden patterns and extracting useful information from the data we use. So these are the major reasons why we are using machine learning nowadays. So comparing to better computing system, machine learning is very important and useful for us. Now let us see the related fields that are related to machine learning. There are various fields they are related to machine learning. Some of them are artificial intelligence, data mining, probability and statistics, information theory, numerical optimization, and computational complexity theory, and control theory, and psychology, neurobiology, linguistics, and philosophy. Where artificial intelligence is the main feature of machine learning because machine learning is a subset of artificial intelligence. Now let us see about the levels of learning training in machine learning. There are many learning methods involved in training. Usually training is the acquisition of knowledge, skills and competences as a result of the teaching of occasional or practical skills and knowledge that relate to specific useful competencies. Training is the major part in machine learning because training gives the machine or data set and then it gives knowledge about the data set and it practices machine to learn from it. So training plays a major role. Without training, a machine cannot learn on its own. So training is very important part in machine learning. Now let us see an example of training. For example, we can consider if a student is going to attend an interview, he should take a training for at least 1 or 2 months because without a training no one can succeed in anything. He or she should take a training in placement or regarding courses which they are learning in their day-to-day life. So this is the basic example of training. Same, this concept is used in the machine learning. Now let us move on to the next slide. In this slide, we are going to see about the types of training experiences. There are two types of training experiences. They are direct or indirect, which means direct means with a teacher, indirect means without a teacher. Firstly, let's come to direct. Usually, we are learning any new things with help of a teacher. But if a student study alone in home, will not learn with the help of the teacher. This can be considered as an example of direct or indirect training experience. In direct experience, there will be a teacher or coordinator who will help you to learn out new things. But in indirect training experiences, there will be a no teacher or coordinator to help you out. You should learn on your own. This is a basic example of a training experience. And then we can see about an eternal problem. Eternal problem means make the training experience representative of the performance goal. Now let us move on to next slide. In this slide, we are going to see about the types of training. There are four types of training, but mainly we will use only three types. So the four types of training are supervised training, unsupervised training, and the reinforcement training and semi-supervised training. Supervised learning is usually a series of labeled example with a direct feedback. But in unsupervised learning, there will be no feedback. In reinforcement learning, there will be an indirect feedback. Firstly, let us see about supervised learning. Supervised learning is a type of machine learning in which we provide sample labeled data to the machine learning system in order to train it, and on that basis it predicts the output. The system creates a model using labeled data to understand the data set and learn about each data. Once the training and processing are done, then we test the model by providing a sample data to check whether it is predicting the exact output or not. Usually, the goal of supervised learning is to map input data with the output data. The supervised learning is based on supervision, which means there will be a teacher or coordinator to teach you something out. For example, when a student learns things in the supervision of the teacher, uh, let's consider a scenario of an exam. Usually, supervised learning is grouped into two categories of algorithms, their classification and then regression. Now, let us see about unsupervised learning. Unsupervised learning is also a learning method of machine learning, in which a machine learns without any supervision. That means there will be a no teacher or coordinator to teach you out. This training is provided to the machine with a set of data that has not been labeled, classified, or categorized. And then the algorithm needs to act on the data without any supervision. Usually, the goal of unsupervised learning is to restructure the input data into new feature or a group of objects with the similar patterns. Unsupervised learning has the same two categories of algorithms. They are clustering and then association. Now let us see about reinforcement learning. Reinforcement learning is a feedback based learning method in which a learning agent gets a reward for each right action and gets a penalty for each wrong action he does. And then the agent learns automatically with this feedback and improves its performance in reinforcement learning. Reinforcement learning has a goal of an agent to get the most reward points, and hence it improves its performance. Now let us see an example of reinforcement learning. A robotic dog which automatically learns the movement of its arms is an example of reinforcement learning. Now let us move on to next slide. In this we are going to see about types of testing. Usually testing means analyzing a system whether it is correct or wrong. In this we are going to evaluate the performance by testing on data. It should be randomly sampled, and then cross validation methods are used for small data set. Usually, testing means analyze of a system whether it will work in a perfect manner or not. and then testing will work only based on a particular system. So now let's say about generalization. Generalization means performance on unseen or unknown scenarios or data. It can be brittle or robust performance. Now let us move on to the next slide. Now consider this image. Can you find any difference among the pictures given in the image? Uh, the first picture is a picture of a lion, which is in a small size, and in second picture is also of a lion, which is somewhat bigger compared to the first one, and then the third picture is also of a lion, and then the final picture is of a frog. So among these pictures, frog is a different one. Other pictures are same, but they have some similarities between them. So frog is a different one in this picture. Let's move on to next slide. In this, we will see about the usual machine learning stages. They are hypothesis, data, and then training or learning, and then testing or generalization. Which means training or learning is the same field which has similarities between them, and then testing or generalization is also a same field which have similarities like a training or learning process. So now let us see why machine learning is necessary. Learning is a hallmark of intelligence. Many would argue that a system that cannot learn is not intelligent. And then without learning everything is new. We can consider a student entering into a academic year newly. He will learn nothing, but after learning he will gain more knowledge. So same will work for a computer also. A computer also learns everything from the past data and will work according to it. A system that cannot learn is not efficient because it redrives each solution and repeatedly makes the same mistakes. So let's consider the example of a student. If a student does not learn anything and then automatically they will fail in an exam or test. Same will happen in a system. If a system does not learn anything, it is considered as an inefficient. And then why learning is possible? Because there are regularities in the world, so learning is possible. Now let us see the different varieties of machine learning. There are various varieties of machine learning. Let us see some of them. Uh, there are concept learning, clustering algorithms, connectionist algorithm, genetic algorithms, and then explanation based learning, transformation based learning, reinforcement learning, case based learning, and then macro learning, and then evaluation functions, cognitive learning architectures, and constructive inductions, and then discovery systems and knowledge capture. So these are the different varieties of machine learning which are available in today's world. Now let us see about task, which means defining the learning task. So let us consider task as T, and then performance is considered as P, and then experience is considered as P. So these are the three factors which are used in this given scenario. We can consider various scenarios for these factors. Firstly, we can consider playing checkers. Okay, for T means task. So playing checker is one of the work we are doing. So it is a task. And then performance metric. It is considered as P, which means percentage of games won against an arbitrary opponent. So let us consider the total percentage they have won against the opponent. And then E means experience. So while playing, they are learning many new techniques and then gaining more experiences. So playing practice games against itself is considered as an experience team. And then let us consider another scenario. So the task is recognizing handwritten words, and then P is defined as percentage of words correctly classified, and then E is defined as database of human labeled images of handwritten words. And then let's consider another scenario. The task is to find driving on four-lane highways using a vision sensor, and then experience is defined as an sequence of images and steering commands recorded while observing a human driver, and then P is defined as average distance traveled before a human judged error. So let's consider another scenario which will be helpful for you to learn. And then the task is to categorize emails such as spam or unspam. And then the performance is to find the percentage of email messages correctly classified. And then the experience will be usually on the past data, whether there are emails of any spam or unspam. So now let's move on to the next slide, which is designing a learning system. Usually, learning system will be designed based on many factors, which comes under machine learning. Now let's consider some of the important factors. They are training, which has a target function, and there will be a task, experience, and the performance of the given task. Firstly, to design a learning system, we should choose the training experience and then choose exactly what is to be learned. We should correctly desire what topic should be learned before we have start developing a learning system. That means choosing a learning process is known as target function. We have to choose what topic we are going to learn. That topic is called as target function. And then next step is to choose how to represent the target function. We have selected a target function, and then we have to choose how to represent the target function. After completing this step, we are going to move on to next step. It is choosing a learning algorithm to infer the target function from the experience. We should choose a learning algorithm based on their past experience. There are three steps. Firstly, we should choose a target function. Secondly, we should represent a target function. Thirdly, we should define an algorithm from the past experience. These are the important steps while designing a learning system. So now let's come to training experience. So usually training experience has two types. They are direct experience and then indirect experience. So in direct experience, there will be a given sample input and output pass for a useful target function. So let's consider an example of a game. A checkerboard labeled with the correct move extracted from record of expert play. Okay. In this game, there will be a label dataset which has the datasets of correct moves. It is known as direct experience, which means there is a label dataset to predict the output. In indirect experience, it is represented as given feedback, which is not direct for a useful target function. For example, sequence of game moves and their final result. So, in this experience, they have given a sequence of game moves and the final result only. They have not given the correct moves. But in direct experience, they have given the correct move. In indirect experience, they have not given the correct move. This is a difference between a direct and indirect. In direct experience, they have given the label dataset, but in indirect experience, they have not given the label dataset. Okay, now let's see about credit or blame assignment problem. We are going to find how to assign credit blame to individual moves given only in indirect feedback. Okay, now let's move on to the next slide, which is training versus test distribution. We have seen about training and testing both. Now we are going to see the difference between them. Generally assume that the training and test examples are independently drawn from the same overall distribution of data. If examples are not independent, it requires collective classification. If the test distribution is different, it requires transfer learning. If examples are not independent, means we should use collective classification. And then if the test distribution is different, means we have to use transfer learning. So, we will see the difference between training and testing. Usually, training and test dataset are the two key concepts of machine learning, where the training dataset is used to fit the model and the test dataset is used to evaluate the model. Training dataset is usually used to fit the model and the test is used to evaluate the model. So let's firstly say about what is meant by training dataset. The training dataset is the biggest subset of a original dataset which is used to train or fit the machine learning model. Firstly, the training dataset is fed to the machine learning algorithms which lets them learn how to make prediction for the given task. And then in test data set is defined as once we train the model with the training data set, it's time to test the model with the test data set. This data set evaluates the performance of the model and ensures that the model can generalize well with the new or unseen data set. The test data set is another subset of original data which is independently of the training data set. However, it has some similar types of features and class probability distribution, and then it uses a benchmark for model evaluation once the model training is completed. Usually, test data is a well organized data set that contains data for each type of scenario. The testing data should be represented or part of the original data set. It should be large enough to give meaningful predictions. Okay, now the training is used to train the model and the testing is used to test the model after the training process. Now let's move on to the next slide. It is choosing a target function. Target function is defined as choosing a topic for building our model. So let us consider an example of an game which is a checker. So for checkers, assume we are given a function for representing the legal moves for a given board position and want to decide the best move. Our task is to find the best move. So now we are going to create a function which is called as choose move board comma legal moves. This is known as a function. And then we are going to evaluate a function which is called as v board. V can be used to pick a move by applying each legal move, scoring the resulting board position. So now we are going to represent the target functions. Firstly, we have chosen the target function and then we are going to represent this target function. Okay. Now target function can be represented in many ways. They are lookup table, symbolic rules, numerical function and neural network. And then in target function, there is a trade-off between the representation of the learning, and then the more expressive a representation the better it will be. So after representing the target function, we can move on to linear function for representing. So we have considered a game called checker. We use a linear approximation for evaluating the function. We have created a function and then we have created an evaluation function which is called as VB. So now we are going to create a linear function for that evaluation function. So the linear function for that is V of B equal to W of 0 plus W of 1 dot VP of B plus W2 dot RP of B plus W3 dot BK of B plus W4 dot RK of B plus W5 dot BT of B plus W6 dot RT of B. So this is a linear function for evaluation function. BP of B is represented as number of black pieces on board. RP of B is represented as number of red pieces on board. BK is represented as number of black king, and then RK is represented as number of red kings, and then BT of B is represented as number of black pieces threatened, and RT of B is represented as number of red pieces threatened. And then we are going to see about the learning algorithm. In learning algorithm, we use training values for the target function to introduce the hypothesized definition that fits these examples. Usually in statistics, learning to is used to approximate a continuous function that is called as regression. And then there are various attempts to minimize some measures of error that is called as mean squared function, and then this is an formula for a mean squared error function. Now let's say about least mean square algorithm which is known as LMS. A gradient descent algorithm that incrementally update the weight of a linear function. Okay, in this we will consider an training example B. So firstly we will compute the absolute error. The formula for the absolute error is V train of B minus VB, and then for each feature we need to update the weight. The weight formula is Vi equal to Vi plus C dot Fi dot error of B. This is an LMS algorithm formula. And then now let's move on to the next slide. In this we will see about various function representation. Usually function has various representations in it. Some of the representations are numerical representation, symbolic representation, instance based representation, probabilistic graphical models. So in numerical function we will use only a combination of numbers to represent a function, but in symbolic functions we will define a sequence of symbols to consider the function. And then in probabilistic graphical model we will define a graphical structure for defining the functions. In numerical function there are various types such as linear regression, neural network, and then support vector machines. Neural network is an network inspired from the human brain. It works on the inspiration from the human brain. It has three parts such as input layer, output layer, and then hidden layer. And then in symbolic function we will consider any symbols to represent the function such as decision trees, probabilistic logic, first order predicate logic. And then in instance based function we use nearest neighbor KNN algorithm, which means K means nearest algorithm, and then case based. And then in probabilistic graphical model we use the following algorithms. They are naive bayes, Bayesian network, hidden Markov models, probabilistic content free grammar, and Markov networks. So these are the various function representations. So now let's see about the evaluation of learning system. So there are two types of learning, which will be an practical or experimental learning, and another type will be a theoretical learning. Usually in experimental or practical learning we will experience by touching, and then by participating in it. For example, let us consider playing chess in both online and offline mode. Playing offline mode is an example of experimental because we are experiencing by moving the coins with help of our hand, and we will know how to move it correctly. But while playing in offline mode, we will not have that practical experience while playing in online, but while playing in offline we will have that exact practical experience. So it's better to learn experimental or by practically. In And another type of learning system is theoretical. Usually theoretical is defined as it consists of many theories. We will just learn only by a theory or definition. This type of learning is called as theoretical learning. um, in theoretical learning, we will analyze algorithms mathematically and prove theorems based on their computational complexity, ability to fit training data, and the sample complexity. Okay, now let us move on to next slide. In this, we are going to see about the history of machine learning. Okay, firstly, before some years, machine learning was science fiction, but today it is the part of our day to day life. Machine learning is making our day to day life easy, from self driving cars to Amazon virtual assistant Alexa. However, the idea behind machine learning is so old and has a long history. So, let us see one by one, one by one. The early history of machine learning starts from the before 1940. In 1834, Charles Babbage, the father of the computer, conceived a device that could be programmed with punch cards. However, the machine was never built, but all modern computers rely on its logical structure. In 1936, Alan Turing gave a theory that how a machine can determine and execute a set of instructions. Okay, the era started stored program of computers. In 1940, the first manually operated computer, ENIAC, was invented, which was the first electronic general purpose computer. After that, stored program computer. In 1949, ESAC was invented, and then in 1951, EDVAC is invented. In 1943, a human neural network was modeled with an electrical circuit. In 1950, the scientists started applying their idea to work and analyzed how human neurons might work. Okay, now we will see about the history of computer machinery and its intelligence. In 1950, Alan Turing published a seminal paper, Computer Machinery and Intelligence on the Top of Artificial Intelligence. And then now we will see the history of machine intelligence in games. In 1952, Arthur Samwell, who was the pioneer of machine learning, created a program that helped an IBM computer to play a checkers game. It performed better more it played. In 1959, the term machine learning was firstly coined by Arthur Samwell. And then okay in 1950, Samuel checker player game was developed, and then self-righteous pandemonium was developed, and then in 1960s, neural networks, which is known as perceptron, was developed, and then pattern recognition, learning in the limit theory, Minsky and Papert prove limitations of perceptron were developed in the year of 1960. And then in 1970, symbolic concept induction, Winston's arch learner, expert system, and the knowledge acquisition bottleneck, and then scientific discovery with background, mathematical discovery with AM were developed in 1970s. And then in 1980s, uh, developed so many machine learning techniques such as advanced decision tree and rule learning and explanation based learning, and then learning and planning and problem solving, and then utility problem analogy, cognitive architectures, and then valiant pack learning theory, and then focus on experimental methodology. In 1990, we have developed data mining, adaptive software agent and applications, text learning, and then reinforcement learning, inductive logic programming, ensemble such as bagging, boosting, and stacking, and then Bayes net learning. And then in next slide we will see the development in 2000s. There are various developments in 2000. They are support vector machines, kernel method, graphical models, statistical relational learning, and then transfer learning, sequence labeling, and then collective classification and structured outputs, and then computer system applications such as compiler debugging, graphics security, and then email management, and then personalized assistant that learn and learning in robots and machines. Now let us see the common development of machine learning. The first AI winter was developed during the year 1974 to 1980. It was a tough time for AI and ML researchers, and this time is called as AI winter. And then machine learning, from where it has been developed from theory to reality. In 1959, the first neural network was developed, and 1985, a neural network NetTalk was to reach a pronounce of 20,000 words in 1 week. And then machine learning at 21st century developed um, deep learning, which is one of the feature of a machine learning. And then in 2012, Google created a deep neural network which learned to recognize the image of human and cat in YouTube videos. And then now machine learning at present has many developments in it. So now machine learning has got a great advancement in its research, and it is present everywhere around us, such as self-driving car, Amazon Alexa, chatbot recommender system, and many more. And then it includes supervised, unsupervised, and reinforcement learning with clustering, classification, decision tree, and SVM algorithms. Modern machine learning model can be used for making various predictions, including weather prediction, disease prediction, stock market analysis, etc. So these are the history and developments of machine learning. Now let's see about supervised learning classification. Usually supervised learning has a labeled data set to predict the output. Now we can consider an example of cancer diagnosis, where we have a patient ID, tumor, I mean number of tumors, and then its average area, average density, and then diagnosis. This is the training data set we are going to use. And by using this training data set, we are going to learn how to classify patient where diagnosis is not known. So the test data set, which consists of patient ID, number of tumors, average area, average density, and then diagnosis. So by using this both training and test data set, we are going to predict the output. Usually the test data set will be given as an input data. That is, input data is often easily obtained, whereas the classification will not be easily obtained. Okay, now let's move on to the next slide. In this, we are going to see about the classification problem. Our goal is to use training data set plus some learning method to produce a predictive or statistical model. Using this predictive model, we are going to classify the new data. So some of the sample applications are, let us see the applications and their input data and their classification. Let us see one by one. Firstly, we can consider medical diagnosis. Their input data is non-invasive test, and then their classification is result from invasive measurement. Secondly, optical character recognition. Their input data is scanned bitmap, and their classification is letter A to Z. Thirdly, we are going to see protein folding. Their input data is amino acid construction, and their classification is protein shapes. And then finally, we are going to see research paper acceptance. Their input data is words in paper title, and their classification is paper accepted or rejected. So these are the classification problem in the supervised learning. Now let's move on to next slide. In this, we are going to robotics and machine learning. Usually robotics and machine learning are a similar one, because a robot is a machine which learns from the past data, and it will work like a human, or it can be a dominant for a human. So these both the features are similar. So we can see where the robots are used. Robots are used in many fields. Some of them are industrial robots, military, government, and space robots. And then robots are used in healthcare, laboratory, and home. Okay, there are so many fields where we can see robots nowadays. And then we are going to see why robots are used. Okay, now we are going to see why we have used robots. We use robots in dangerous tasks, which will be helpful in protecting us, and then we will use robots in a repetitive task, because while doing a task repeatedly will be an irritating thing, and then it will consume more time. But while using robots, it will be a easier task. And then we can use robots in high precision tasks which requires high quality, and then it will lesser labor savings. And then the control technologies used in robots are autonomous, self control, and then teleoperated, which means a remote control. And then now let's see now let's move on to next slide. In this we are going to see the uses for robots in manufacturing. We are going to see the uses of robots in manufacturing. Robots can be used in welding, painting, cutting, dispensing, assembly, finishing, material handling, packaging, machine loading. A robot can do any kind of work in manufacturing, because it is in designed in such a kind of thing, and the robots can do a piece of work very clearly and give it a crystal finish. And then we are going to see uses of robots in automotive industry. In robots can be used in welding and handling of fuel tanks from many manufacturing companies. This is investigated on a Discovery Channel how it is made. This is a system I worked on in 2003, and then which means a Discovery Channel, they have witnessed how robots work in a manufacturing company. And then in manufacturing company, robots also worked in many fields such as packaging, especially in food manufacturing. Now let's move on to next slide. So this is an example of industrial robot working in an automotive system. This picture will depict how a robot will work in a automotive industry. And then military or government robot. This is an example of government robots which is used in a military or army sectors. These robots play a major role in military and army sectors. um, this picture will give you a reference of it. Now let us see the same which we have seen before. It's a military robot. Soldiers in Afghanistan being trained how to defuse a landmine using a packed bot. This is the picture how a soldier will be trained. And then we are going to see about the military robots again. They are aerial drones and then military suit. Aerial drone is also one kind of robot, and then military suit is also one kind of robot. This is a representation of that. And then we are going to see about space robots. Robots are used in all kind of fields such as water, air, space, and then military, etc. So in space it is used in Mars rovers. Autonomous navigation features with human remote control or inbuilt within that robot. And then we are going to see about the services provided in the robot. A robot have many services such as cleaning and housekeeping, humanitarian demining, rehabilitation, inspection, agriculture and harvesting, lawn mowers, surveillance, mining applications, construction and automatic refilling, and firefighters, and then search and rescue. So these are the services provided by our robots. And then let's see the application of robots in medical and healthcare. A Japanese healthcare assistant suit. This is one kind of robotic application. This is the representation of that. And then let us see the application of a robot in laboratory. Robots are used in drug discovery. This is a representation, and then it is used in test tube sorting also. So now let's see about Scout robots. Scout robot has 16 sonar sensors, and then it has a laser range, scanner, odometry, and a differential drive, and simulator, and API and C. This is the representation of the Scout robot with its specifications. And then let's see about the Let Go Mindstorms. This is one type of an robot. It has touch sensor, light sensor, rotation sensor, video cam, and motors in it. And then we are going to see a general model of learning agents. This is a representation of that, where there will be a agent. He will learn from a past experience, from a environment, and then there will be many factors which change their learning environment, and there will be a performance metric to detect their learning, and there will be a problem generator also to test their learning process. Now let's move on to next slide. Let us see the disciplines related to machine learning. So there are various disciplines related to machine learning. Some of them are artificial intelligence, Bayesian methods, control theory, information theory, computational complexity theory, philosophy, psychology, and neurobiology, and statistics, and many practical problems in engineering and businesses. So these are the disciplines relevant to machine learning. Now let's move on to next slide, where machine learning can be used as a function approximation, classification, and then categorization, prediction, and pattern recognition. Machine learning normally will be used as a categorization, prediction, and pattern recognition. So these are the platforms where machine learning can be used. Now let's move on to next slide. In this, we are going to see the real world applications of machine learning. Machine learning is a buzzword for today's technology, and it is growing very rapidly day by day. We use machine learning in our day to day life even without knowing it, such as Google Map, Google Assistant, Alexa, or the common real world applications. So here we use Google Orbits and then It is used in astronomy. Let us see some of the working applications of ML. The working applications of machine learning are classification of mortgages, predicting portfolio performance, electrical power control, and chemical process control, and character recognition, face recognition, DNA classification, credit card fraud detection, and then cancer cell detection. And so let us see some more applications in our real world. The applications of machine learning in real world are image processing, speech recognition, traffic prediction, product recommendation, self-driving car, and it is used in email spam filtering, and then it is also used in virtual personal assistants such as Alexa, and then online fraud detection. It is used in stock market trading also, and then it is also used in medical diagnosis. Now let us move on to the next slide, where we will be seeing about the issues in machine learning. There can be some of the issues in machine learning. Let us see. Um, the issues in machine learning are problem representation or feature extraction, and then integrating learning with systems, and then transfer learning and continuous learning. Usually, feature extraction is defined as extracting the particular property of a given picture or data set, etc. So this is considered as an issue in machine learning, because while extracting we will have a bias which will be considered as an error in machine learning. And then now let's see about the measuring performance. The measuring performance can be measured by using the following properties. They are generalization accuracy, solution correctness, and then solution quality, and it will have the speed of performance. Now let's move on to the next slide. They are We are going to say about the scaling issues in machine learning. There are many scaling issues in machine learning, such as number of inputs, number of outputs, and then number of batch versus number of real time, and then number of training versus number of testing. And then we are going to see about the observations which have been observed in machine learning. Machine learning has many practical applications and is probably the most used method in AI. And then machine learning has active research area, and then it is used in the role of neuroscience, and then all ML is still dependent on human guidance. Now we are going to see about machine learning versus human learning. Now we are going to see the difference between a machine learning and the human learning. Okay, some ML behavior can challenge the performance of human expert, such as playing chess. Now we can consider the game of a playing chess, where a machine learning can challenge a human expert. Although ML sometimes matches human learning capability, it is not able to learn as well as humans or in the same way that humans can do. It means a machine cannot learn in a way that a human does. And then there is no claim that machine learning can be applied in a truly creative way. And then usually machine will learn from the past data, so there is no possibility that a machine can learn in a creative way. And then there are formal theories of ML system exist but are often lacking. There are many formal systems in ML, and then machine learning is often attributed to manipulation of the symbols. It can be numeric, and then a probabilistic graph, or it can be symbolic. Okay, these are the basic concepts in machine learning. Um, now we came to the end of the session. In this session, we have learned about the introduction to machine learning, its types, and then training types, and then how testing and training works, and then history of machine learning. We have seen about robotic concept in machine learning, and then we have seen many features of machine learning, advantages of machine learning, and then we have discussed the issues in machine learning. So these are the basic concepts we have discussed in machine learning. Now let us end this session. Thank you. Thank you. I hope you understand the machine learning concepts very well. Thank you.